All right, thank you everyone so much for joining us today for today's Lunch and Learn in honor of National Estuaries Week. National Estuaries Week is a nationwide celebration of our estuaries and all the benefits they provide. So we're happy to see you all here today to learn more about our estuaries right here in our own backyard. We also hope you'll take the chance, weather permitting, let's all send that hurricane energy somewhere else, that you'll have a chance to get out and explore this week or this weekend as well in our local estuaries. Just a little short housekeeping. We're going to hold questions till the end of the presentation. So if you do have a question, you're welcome to drop it in the chat. If you're worried you're going to forget it as we go through. Towards the end, when we get to the questions, if you could just either, again, drop that question in chat, or you can raise your hand and our presenters will call on you one-on-one to get those questions answered. And then we're going to ask that you just limit to one question for the start. So if you have a follow-up question, let's let some other folks get their questions answered first. And then we can always come back to y'all if you're able to stay on and join us. And then please remember to stay muted during the presentation. And without further ado, we are going to get started. Before I pass it over to Haley, everyone feel welcome to drop a happy birthday to Thomas, one of our presenters, in the chat as well. He's doing us the honor of presenting on his birthday. So happy birthday, Thomas. And Haley's going to take us away.
All right, well, thank you all for being here today. So I'm Haley Gancel. I'm the environmental scientist for the estuary program. Today, we're going to be talking about some of our monitoring activities that we do concerning seagrasses and then also juvenile fish communities. So the title of our talk today is, Are the Tides Turning for Our Seagrass and Fish Communities? All right, so for some of you new folks out there that may not know much about the Pensacola and Perdido Bays Estuary Program, we are a non-regulatory program. We focus on restoration of our watersheds. We focus on education, so K through 12 education, but also adult education as well. And then also we focus on unbiased monitoring of our watersheds. So we're going to talk a lot about our seagrass and fish monitoring that we do, and that we do in partnership with many people across the watersheds and what that ultimately means. Okay. All right, so here's a great map that shows the coverage that our program, does our programming across. So in this type of green over here, this is the Perdido Bay watershed. And then the funner color of this green is the Pensacola Bay watershed. So what's important to note is that our watersheds cover a very wide area. So you'll notice that for both Perdido and Pensacola Bay watershed, we extend all the way into Alabama. So our program takes a watershed approach to restoration, education, and monitoring. So really what that means is that everything that happens upstream, in Alabama, it eventually makes its way downstream into our bays and bayous. So we focus on not only Florida, but also Alabama. Something else that's really important about our program is we are non-regulatory. We were formed back in 2018, but because we are non-regulatory, we don't directly advocate for specific scientific changes in our community, but we do have local elected officials on our policy board or our board of directors that we then communicate that science to in hopes that they have that power to enact the change. The last thing that's really important about our program is that we are a stakeholder, community-driven organization. So that really means that the goals and actions that our program follows is based on community input. So it's not just what the staff wants, it's what we gather from the community. Okay. So back in October of 2022, we developed our first comprehensive conservation and management plan, or CCMP. So this is the blueprint or the roadmap that guides our program. Okay. So this was a document that we did not make in a vacuum as staff. We had many community engagements and different types of agencies and stakeholders that came to the table to really tell us what they wanted to see happen across the watersheds. So out of that management plan and that process, we came away with 6 CCMP goals, right? So things such as being the source of watershed information, strengthen community resilience, improve water quality, reduce sediment sources, conserve and restore critical habitat, and restore and conserve fish and wildlife. And for this talk today, we're focusing on some of our monitoring efforts that we do with our partners. And we're going to be focusing on goal 5 and 6. So we're going to be talking about seagrass habitats and then also some juvenile fish surveys that we do. All right, here's a video of some local seagrass beds in our area. You should be able to see some fish rolling by. So if you are not familiar with what seagrasses are, they are underwater vegetation that is stuck in the sediment, so it's permanently there, and they have rhizomes that grow along the seagrass beds. And they're really important habitat for juvenile fish species, also bivalves and other crustaceans. They're also really important to help stabilize our sediments and to help reduce nutrients in the water column. Something else that's important to note about seagrass habitats is that they really thrive in low nutrient and high light conditions. And so those are when they're at their healthiest. All right, so long-term monitoring of seagrasses and then also juvenile fish within those seagrasses can tell us some really important things. Mainly, we look at them as environmental indicators of environmental change. So changes in seagrass species or seagrass density or different types of juvenile fish within seagrass habitat, they give us an indication of how the environment may be changing or staying stable. Also important for seagrasses, different species of seagrasses are going to be prevalent in different environmental conditions. So whether that's in higher or lower salinities, higher or low light conditions, or temperature variations, those are going to dictate what type of species are going to be prevalent. And with these long-term monitoring efforts that we're talking about today, we're really trying to track changes over time to see if things are changing, and if they are changing, are they changing in a positive or a negative direction? And if it's a negative direction, is corrective action needed? Also, with our monitoring efforts, we use the data for quite a few different products that we do. So one of those being our State of the Bays report. This is an online website that was really made for the public to be able to go to that website and click through some different indicators to really get an idea of how the health of the bay is doing. So if you go and look up our State of the Bays report, we do have a section about the health of seagrass beds. Monitoring data can also fit into habitat suitability models. So with these models, you're kind of looking at where the environment is best for seagrasses or fish or whatever type of indicator you're looking at. Another important way we use the data is for restoration targets. So we can go back through time to look at how seagrass, for instance, has changed to try to see if we want to set a restoration or an acreage target, for example. We also use the data for proposals or projects that we go after, and then also for tracking the success of our management plan. So we need to be able to know that we're making positive progress, and tracking our actions with these data is one of those ways. Something else that long-term data has been able to tell us through the recent years, in about 20-ish years, we've started to see that there has been some tropicalization of species. So we're starting to see some of those species that were found more near South Florida. They're now more moving up here into the northern Gulf of Mexico, and we're starting to see them becoming more prominent. So things like common snook, people are really excited about coming up into our area. Emerald parrotfish, and then the red mangrove also re-expanding potentially back into the northern Gulf of Mexico. All right, jumping into some of our seagrass data that we have collected. So this is looking at our 2017 seagrass extent mapping surveys. So with this data, we're looking at where are seagrasses prevalent in our area. This map is only showing Santa Rosa Sound, and then we have two different colors of green. So this bluish green is looking more at continuous patches of seagrass, whereas this lime green is looking at patchy areas of seagrass. All right, Santa Rosa Sound, if you look at this figure, you can see a lot of these green colors. So we do have quite a bit of seagrass extent and coverage in Santa Rosa Sound, and it is relatively healthy. So this is looking at the 2017 data. It was remapped in 2022 by the Dauphin Island Sea Lab. You may notice that this is just one color of green. So we don't have our seagrass extent broken up into patchy versus continuous, but we do see that that seagrass footprint is still pretty widespread. Here are some of the numbers. You might notice the difference between Santa Rosa Sound from the last slide, which was about 3,000, to about Santa Rosa Sound in 2022, which is about 2,500. We will say that the differences in seagrass coverage between 2017 and 2022 are more likely due to the way the methods were done than true differences in seagrass coverage. So for the differences between 2017 and 2022, we more likely think that the seagrass coverage is relatively more stable, and those differences in acreage is just due to different methods that were done. Okay, so those last two maps we're looking at, where is the seagrass found in Santa Rosa Sound? This slide is looking at seagrass monitoring that we have been doing for about the last 3 years. This is an effort that is led by the University of Southern Mississippi with Dr. Kelly Darnell's group. And with this seagrass monitoring, what we're doing is we're looking more at the health of those seagrass beds. So when we go out here and when we monitor the seagrass, we're looking at what species are present, what percent cover of those species are present, what is the canopy height or that shoot density height, and then also is there macroalgal or epibenthic on the seagrass. So in seagrass that are less healthy, you're going to have more macroalgae than in healthier seagrass beds, for example. All right, so in our area, we have 5 main types of seagrasses. On this slide, we're showing 4 of the most common types. Right, so we mainly get shoal grass, turtle grass, manatee grass, and widgeon grass. These are the 4 most common types. And again, the difference in species, whether they're present or absent, is going to depend on environmental conditions such as salinity, light, etc. For the data that we're looking at today, so in Santa Rosa Sound and Perdido Bay, most of the seagrass that we find are shoal grass and turtle grass. And then down below, if you are interested, these are the scientific names that many people know them by. Now, I did say that there are 5 main types of seagrass that we have around here. The 5th one is stargrass, and stargrass is by far the most unique one that we are going to find. So stargrass, a couple years ago, I know Dr. Jane Caffrey, she came across this grass. It was by the Navarre Bridge to the Navarre Beach. And so it's called stargrass because when you see it underwater, its leaves open up like a star, and then everybody gets really excited when they find starfish. It's so rare to find and so exciting. But also, University of Southern Mississippi also went back to that site and they were able to find it that same year. And then when I went out on surveys last year, we were not able to find it, but that doesn't mean it's not there, likely just in a different area. We also complement some of this long-term monitoring data with community science monitoring. So this is data from our Eyes on Seagrass monitoring that is led by Dr. Jane Caffrey at the University of West Florida, and then also Rick O'Connor with Florida Sea Grant. They began this program back in 2017 with a group of community science volunteers. And this map is, or this graph is showing some of the data that they've collected. So on your x-axis, we're looking at the summer data from 2017 to 2022. On the y-axis, we're looking at percent cover. The different colors of green represent different seagrass species that are found. And then the pink are bare patches. Okay. So kind of what's important to note with this is while we do see changes in species percent cover and percent cover through time in these summer months, we are seeing that percent cover of seagrass is relatively stable above 50 to 60% seagrass cover. So those are relatively dense patches of seagrasses that are being found out there, and that it really represents some stable coverage over time. And this complements what's being found with those University of Southern Mississippi surveys, where we do find that percent cover is also 50% or greater. All right, so now this is looking at, it's kind of merging both the seagrass extent with the species data. So in the background, again, so this is Santa Rosa Sound data. The green in the background, that is the 2022 seagrass extent data. And then in these circles and these pie charts, that's representative of the species that were found there. So for example, the gray color are areas where bare patches were found. The greenish bluish color is turtle grass, and then this greenish lime color is shoal grass. So really in like this portion of Santa Rosa Sound, we're finding more turtle grass, and then as we go more east, we're finding more shoal grass. We can look at similar patterns for Big Lagoon and Perdido Bay, and then also Pensacola Bay. So with those University of Southern Mississippi surveys, we also do some surveys up in Pensacola Bay for this year. That this was sampled in 2022, I believe. All of these patches were bare. And then in Big Lagoon, you get some turtle grass. And then in Lower Perdido Bay, kind of near these Lower Perdido Islands areas, we have some more shoal grass. So we can use these data to look at, the species that are present, if they're changing through time, and then also the seagrass coverage. All right, now quickly jumping into some of the data that we get with our juvenile fish trawling surveys. This is a long-term effort that has been done at the Dauphin Island Sea Lab out of Dr. Ken Heck's group. And they've been doing this consistently since 2006. So what they do is they have 16-foot otter trawls that they tow for 4 minutes at a speed of 3 to 5 knots. They take data on a variety of things such as the site characteristics, GPS coordinates, salinity, and temperature. And then they pull the trawl onto the boat and they sort the fish by species. They get total abundance, total length, and then they release the fish. So with these surveys, what they're doing is they're trawling over seagrass beds. So each of these points represents one of their trawling locations. And you may notice that we're looking again at Santa Rosa Sound, Big Lagoon, and Lower Perdido Bay. And so they're trawling over these areas that have seagrass beds to see what type of juvenile fish are present in these seagrass beds. So last year, Logan and Whitney were lucky enough to be able to go out with the Sea Lab on their trawling survey. They collected 25 species of fish at 13 sites. Gray snapper moved up to the top 5 most abundant. So it does seem that there is some trend where we're seeing more and more gray snapper in these trawls. And Big Lagoon had the highest fish catch with greater than 1,000 individuals per kilometer. All right, so this is a graph showing the data that have been collected from 2006 to 2023. On your y-axis, we're looking at mean catch per unit effort. So that's the number of individuals per kilometer that's towed. This is looking at 3 different sites that were trawled. So in the lighter blue, we have Spanish Cove, darker blue is Gulf Breeze, and then this aqua teal color is Naval Live Oaks. We do kind of see a dip from 2007 down to 2018, 2019 to 2021. Those were our COVID years where the Dauphin Island Sea Lab did not go out sampling. And then we were able to trawl with them in 2022 and 2023. And then in October, we are going out for our 2024 sampling. It does look like there is a slight increase in catch per unit effort. Again, this is really only a data point of 2, so it's a bit too early to tell if we're actually trending upward on fish abundance. But we did see more species last year than the previous year, and we are trawling again in October. So stay tuned for those data, and we will hopefully be able to see if this is going to be a trend or not. Okay. So these are some of the common fish species that are found in these trawls. So we have things like emerald parrotfish, plainhead filefish, southern puffer, striped burrfish, chain pipefish, gulf flounder, and scrawled cowfish. And within these trawls, the most common species that are found are things like pinfish, mohara, silver perch, and pigfish. Pinfish is a common bait fish that's used recreationally in our area. The less common species that are found are things like gray snapper, even though gray snapper is starting to trend upward in recent years. Gulf flounder, striped burrfish, pipefish, Atlantic spadefish, and plainhead filefish are also those less abundant species that are found. All right, so what are just some brief takeaway messages from looking at that data? So for seagrass, we have data going back to the 1960s. So these are really long-term data sets where we can look at changes through time. And so from the 1960s to about the 1980s, we saw that about 50% of our seagrass beds were lost, likely from poor water quality and other anthropogenic factors that were happening in the area. But from about the 1980s to 2017, we've really seen that the seagrass beds have been relatively stable from about 3,000 to 4,000 acreages of coverage. And again, our recent mapping efforts from 2022, it showed it was about 2,500 acres, but that decrease is likely more due to differences in methodology than solely acreage lost alone. So for the most part, we're saying that there's really no significant changes from 2017 to 2022. So we've really been stable in seagrass for quite some time now. Also, looking at the species that are present and the percent coverage of those species, we've also seen that that's been relatively stable as well. We're going to continue to try to find funding to regularly map seagrass extent, and then also do seagrass monitoring to look at species and percent coverage as well, so we can track those changes through time. For fish and what they were finding for the fish habitats, over the last 15 to 20 years, so from 2016 to 2018, so this is with those Dauphin Island Sea Lab trawls, there have been some decreases in total fish catch at some sites, but from 2022 to 2023, there was an increase in total fish abundance. Again, it's too soon to really say whether that's a true trend. We are sampling in 2024 and hope to continue that into the future to really see what's happening. And there are many different factors that, can lead to these decreases and increases in fish abundance. So things such as drought, rainfall, storms, water temperature, habitat changes, and plenty of other things can be contributed to those changes. And, we are seeing some tropicalization of some species coming into this area, like common snook and things like that. And we believe that's due to increases in sea surface temperatures. Again, we're going to continue collecting these data. We have trawling and seagrass surveys that are happening this October. And both of these data sets are going to be incorporated into our 2025 State of the Bays. We update this report every 2 years. And so in 2023, we didn't have any fish data. And so we are happy to announce that we're going to be adding fish data to our State of the Bays report. So stay tuned for those data as well. And if you want to see any of our documents, here are some QR codes. I don't know if Logan or Bailey is going to drop any of these links in the chat, but here's our link to our management plan, our State of the Bays website, and an Estuaries 101 website. And then if anybody has any burning scientific questions that they would like to email me, here's my email up here, hngancel@ppbep.org. And then some other QR codes to get in contact with us. And that's it for me. And I know we are holding questions until the end. So I'll pass it off to Rick, I think, or Logan.
Go for it, Rick. If you could stop screen sharing, perfect.
All right, let me get mine up here. All right, we're good. Everybody can see it? Okay, cool. Thanks, Haley. All right, well, good afternoon, everybody, or morning, I guess it's still. Rick O'Connor with Florida Sea Grant. I'm going to be team tag presenting this with Thomas Derbes, who's the Sea Grant agent in Santa Rosa County. And we're going to be talking about the 2024 Pensacola scallop search. So let us jump right into this thing. And it's not advancing. Oh, there it goes. Okay. The bay scallop. This sounds kind of silly. A lot of folks who are on already know a lot about this animal. They grew up in the area. They go to St. Joe to collect them all the time. But we find doing the scallop searches as we're doing our training, there are people who don't know. They've heard of it, but they have no idea what it is or what it looks like. So this is it. This is what the shell looks like. And as I described it during training, I said, look for the thing that looks like the shell gasoline sign. That's the one you're after. It is a bivalve. It's in the phylum Mollusca. So they go along with oysters and clams and mussels. They differ from their cousins primarily in that they're more mobile. I mean, if you look at oysters and mussels, for the most part, they're sessile. They don't really move. Clams can burrow and dig. I've watched them actually flip across sandbars and things like that. So they do have some mobility, but I wouldn't call it fast. They're not a very quick creature. And as far as the bivalves are concerned, this is the real mobile one. Each one of those ridges that you see right here, let's see if I got my arrow, there we go. Each one of those ridges right there does have an eye. They can have up to 50 eyes that do produce, I will say, vision, if you will. It's not anything like ours or at all, but I mean, they can take light and dark, they can pick up shadows, and they are very aware of predators. They sit on the grass instead of burrowing into the sediment like clams do, or attached to each other, as you see oysters and sometimes mussels will do. So when they see or sense a predator, which starfish is a big one, they have a lot of issues with starfish. Blue crabs are one, crown conchs, which is, we're going to add that to our data. We haven't been doing that because we haven't been seeing the scallops. But when they sense those predators, they have a single abductor muscle, which is the muscle that opens and closes the valve. They will contract and relax that very rapidly, and they kind of clap and swim around. And so we call it swimming, but I will say they have no idea where they're going. Steering is terrible, but swimming, but it gets them away from the starfish, which is not a real fast predator. So this is kind of the animal. They are very closely associated with seagrass beds, which Haley just went over, and we're going to talk a little bit. We are collecting actually some seagrass data in the scallop search, which we're about to share some of that. Dr. Caffrey has asked for some of that information. So, but they're closely associated with that. It was a creature that was quite abundant. We'll talk more about that in a second. It was abundant in our bay, kind of disappeared, and I'll come back to that one. So I'm going to move on and let Thomas take the next slide.
Yeah, so as you mentioned, they are bivalves. So if you know anything about the life cycle of bivalves, they kind of have a similar kind of life cycle, life history. Theirs is just a little bit different. The crazy thing about a bay scallop is that it does have the ability to develop both female and male sexual organs. So it can produce both eggs and sperm, which is really a cool thing in the world of aquaculture and in the world of marine biology. In the final stages of development, they use all their energy for reproduction, so they will spit out the gametes. When this happens, they use so much energy when they do that, that their movement really is they really don't have any energy for movement, and this does leave them vulnerable for predation. A lot of the times, this is what leads to them being predated to where they can't spawn a second time. However, scallops do only live about a year, so we usually only get about 1 or 2 spawns out of a scallop. The rapid changes in the water temperatures can trigger bay scallops to spawn. In Florida, we typically like to say in fall they spawn, but that can also change if we have like a cold weather event happen. A single scallop can produce millions of eggs, and I will say that probably only 1 egg out of 12 million is likely to reach adulthood. It takes approximately 36 hours for the fertilized eggs to become tiny larvae. These larvae are known as veligers. They're pelagic, which means that they drift in the water column for about 10 to 14 days. And during that time, they can be carried a considerable distance away from where they were spawned, which helps them distribute out their numbers. When they do settle out, they will settle out and attach to a seagrass blade, and they use a thing called byssal threads to attach to it. I think in this picture right here, you can see a little baby scallop attached right there. That is a baby scallop attached to some turtle grass. They love to attach to turtle grass. That is their favorite seagrass to attach to. Once they attach, it takes a couple of months or weeks for them to become not spat. About 90% of the spat that does settle on the seagrass will perish. And those that do survive, they will detach from the seagrass and they fall to the bottom where they sit for the rest of their lives. So we'll go on to the next one. And I think that's Rick talking about the history of scallops.
Yeah. What I wanted to share with this slide here is sort of the historic range. Again, some of you are old school Pensacola folks and can remember scalloping here. I remember you go to Morgan Park and within 30 minutes you could fill up a bucket full of scallops. Those days went away in the mid 1960s, but their original range was actually up here around Northwest Florida, the Mobile area, and went all the way to Miami-Dade. It actually went all the way through the Florida Keys. So that's the historic range of those things back in the turn of the century. I did talk to an old shrimper. There was a commercial fishery for them for a while in the early part of the 20th century. And he said during the 60s, they would go along. They actually were allowed to shrimp in the seagrass beds that Haley was talking about. And of course, they did a lot of damage and that was causing some concern. So they had to stop that. But they would go along the seagrass beds in Santa Rosa Sound. And as they would come along the points that everybody knows, Range Point, Big Sabine, things like that, he said they would drop a dredge and just kind of pull it for a second. And if they got scallops, then they would drop the bag and start collecting these things. And it was a commercial fishery. It did go away because of the loss of these things. They closed the commercial harvest. There is no commercial harvest in Florida at all anymore. And then slowly but surely, well, actually, I will say, actually, it was pretty sudden, honestly. Around the mid 1960s or so, they literally just disappeared in our area. And we found the same thing from like Tampa south, all through the Keys. Scallops just kind of went away. So today, the larger populations and the ones that you're allowed to recreational harvest, we're all in the Big Bend area. And I'm going to let Thomas talk about that.
Yeah, so as you can see here, this is the harvest zones that they have. You can kind of see it goes a little bit into Bay County, and then it goes all the way down to Tarpon Springs, almost in Pinellas County. As he mentioned, there is no commercial harvest for the scallops, which is, it's a bad thing because that means that there's not enough population to support them. But the recreational scalloping is really strong. It's a really good thing for our economy here in the Panhandle, especially over there in the Big Bend area. They have there's different districts, I guess you can call them, that they do zones that they have for scallops. And what they'll do is they'll go out yearly and they'll go do, at the end of the season, they'll go assess how many scallops were there left over, how many of them were spawned. And then they can go about telling, hey, this is when we're going to open the season up. And then this is how many days we're going to be open because we believe this is how many scallops we're going to be able to have for recreational harvesters to come in and harvest and then leave enough for them to be able to reproduce, because it's hard for them to be able to reproduce if they don't have high numbers. Since they are the batch spawners, like I mentioned earlier, if they don't have high numbers, it's hard for those gametes to meet up. And let me see here. We're back to Rick on the 2015 scallop search.
Okay. Yeah, this slide here is to kind of talk a little bit about the history of the scallop search and how we got it all started back in 2015. They actually began the scallop search down in Charlotte Harbor, down in Charlotte County, with Betty Stargler, our colleague down there, Sea Grant colleague. She started the scallop search down there. They had declined in that part, Southwest Florida also, and she created the protocol and the program. And then myself, Christopher Lindy, and a past Sea Grant agent in Okaloosa, Brooke Sari, we three went down there and actually participated and saw how they did it and brought it back here in the Panhandle. So we started doing this thing. Now, what they do down there is it's a one-day event on a Saturday at a local marina. Everybody comes in. We came back here and tried to do the same thing. The first year in 2015, we had a big show. We did one over at Shoreline Park and another one at Big Lagoon. One of the problems we ran into real quickly is a lot of rain. We kept getting washed out. So we decided to kind of spread it over a period of a month and kind of let the volunteers pick the day they would like to go. So that's basically how the whole thing got started. And like I said, we've been collecting since 2015, almost 10 years now. All right, Thomas, you can talk about our volunteer program.
And we did have a great amount of volunteers this year. And if any are on here, thank you so much for participating in Scallop Search this year. Rick's going to go over the data, but we had some great results from this year's Scallop Search. But for a volunteer training, I think that is the group from Chicago. We had a couple groups from Chicago and from other places in the South, which is really cool. They would meet us at the boat ramps, and we would have all the supplies for them, and we would give them a quick little training, show them to what they're looking for, how to measure the scallop, what kind of seagrasses they're looking for. The best thing about being close to the water when we're doing this training is that we can actually go up to the seagrasses and tell them what the difference of seagrasses are. Because if you ask some normal people what a shoal grass and a manatee grass looks like, they look really similar, but when you put them in your hands, it's a lot different. Go over how they run the transect, take the data, and they usually do 3 to 4 transects, so they get to switch teams when some person gets to be the data writer while the other ones gets to snorkel. Usually takes them about an hour and a half, and our trainings take about 15 minutes, and it's a lot of fun. It's my first year doing it, and I can't wait to keep doing it more. And I will go on to Rick. I just kind of went a little bit on how they do it. I guess he can go a little bit more in depth. So
yeah, I'll tell you a little bit of the more details of it. This is basically how it works. And Thomas is going to go over the grids and how they are selected. But once they select a grid, and we let the volunteers to select the grid they would like to do, you can see that here's one of the buoys, and you'll see one way down here above the letter U. That's the other one. It's a 50-meter transect line. And so they stretch it out. The volunteers have a 1-meter PVC pipe, and they hold that against the line. So you can see you got two snorkelers here on each side, and they will swim the line down to that other end with the PVC pipe touching the rope. And so that gives us a quantitative area of measurement. So it's basically 100 square meters is what they're doing. The other thing that the PVC pipe is that we found is good for, especially this year, a lot of these scallops, and I know I saw Keith was on, a lot of the volunteers told us that they actually bumped into them other than seeing them, and then they would swim, that they may have actually missed them. I know a couple of volunteers told me they stopped to get a breath of air and they stood up and they stepped on one. So the PVC pipe, in addition to giving us a measured area, actually helps induce the scallops to move so that you can find them. So that's what they do. They'll swim down there to the end of the line, and then they got a data sheet they record. Usually they work in teams of 3, 2 snorkelers and a data note taker. They fill the data out, as he said. They'll fill out information on how many scallops. They do measure the first 5 that they find. And then we got some information about the sediment. We get information about the seagrasses that they saw, and all of that goes into data. And then they move the line. They do actually 3 lines in each grid. And so when they're done, then they return. So we'll let Thomas talk about the grids.
Yeah, and I'll go over this quick because I know we're running low on time. Here's the Santa Rosa, or not Santa Rosa, sorry, Big Lagoon grid. It only has 11 grids. We separated up into, Rick, you can correct me if I'm wrong here. It's a square mile, or nautical mile. I can't remember which.
Nautical mile, right?
Square nautical mile. Thank you very much. And they don't have to cover the whole square. They just go out and find a portion in that square, and then they'll sample that 4 times in that little area. So this is the Big Lagoon. You can see they've got 11 sampling sites. The best ones that we seem to be finding were closer to 11 and 6. And then we move over to the big grid sites, which is Santa Rosa Sound, and we have 55 sites, and that's the same nautical mile, square nautical mile. And as you can see here, it's a lot bigger. We had more coverage actually in Perdido Bay than we did in Santa Rosa Sound, obviously, because you can see how big it is here. But that is how we break it down, and this is actually done through the FWC. So
yeah, they did the grids for us. They set it all up for us. All right, let's see here. I'm going to have to make the pictures smaller so I can see the numbers. Here we go. Here's the data from Big Lagoon from 2015 to 2024. And so what you'll see yearly, you'll see the number of transects, quite a few. It's a very popular event. As Thomas said, we had groups from Chicago. The last 2 years, we've had a marine science class from the University of Southern Mississippi come over. We've had families come from Dothan, Alabama to do this. So, you know, we get a lot of participation in it. But you'll notice we had a lot of transects. Then we got into the COVID years. Things kind of slowed down. And you'll notice popularity. We had a record number of transects in Big Lagoon this year, and they seem to be getting more and more. Our first, you'll see lots of zeros, a lot of zeros in there. And you guys who've lived here around for a while know, you know, no one's seen scallops in a while. But we saw our first scallop in Big Lagoon in 2020. And you're calculating the number of scallops per 200 square meters. This is the metric that FWRI uses for classifying the status of scallops, and I'll show you that in just a second. Then again, we had our COVID years, not a lot of activity, and then all of a sudden last year, as you can see, we got 2, and then this year 101. It was, and actually this is just from our project. I heard all kinds of anecdotal reports that people find them in all other kinds of places that weren't associated with our project. So there were a lot of scallops out there this year, as far as from our data. And you can see again, the number of scallops is up to 3 per 200 square meters, but overall it's still less than 1. And if you look at Santa Rosa Sound, the first comment I'll put in there, it shows no transects from 2015 to 2020, but we did. The transects, Santa Rosa County was running that, and we had an intern that was logging it, and I did not have access to that for this presentation. So I know there were transects done. I also know that there were no scallops found. So the scallops per 200 square meters is on, but again, as far as the effort, that's not there. But you'll notice here, just like we've had with Big Lagoon, a lot more activity, record number of volunteers and transects done in 2024, and the same thing. We found 32 scallops this year versus say 2, and you'll see still less than 1 scallop per 200 square meters. But the numbers are climbing. It's kind of interesting. And if you look at the next one, this is FWRI's, the research group with FWC. This is the top box, kind of breaks down how they classify it. So 2 or less scallops per 200 square meters, you have a collapse system. And as you guys saw, we're less than 1. So even though it was exciting this year and we found a lot of scallops, it's still a collapse system. And you'll see it for this year, it still collapsed in Santa Rosa Sound, though with the numbers we got in Big Lagoon, it do move across the mark to the vulnerable state. So we'll see what happens. It's interesting talking to some FWC biologists. Scallops are known to do sort of a boom bust population cycle. So you see this in deer and other wildlife as well, that there'll be just a great year, and then next year everything will go back to the way it was. So we'll have to wait and see what next year brings, but it was a busy and exciting year, I'll be honest with you. So that's the bay scallop. That was one of them found this year, and I will stop sharing and turn it back over to Logan.
Well, I do have one more thing I want to input on the
Okay.
scallops just for everybody. Yeah, even though we're seeing these great numbers, we have to have higher numbers for these scallops to be able to reproduce. So even though we're seeing these higher numbers, we can be really excited about it, but the true test is going to be what happens next year. So if you are really interested in doing the scallop search, this is kind of my plug for next year. Go on ahead and get signed up with us, because we're going to try to do a really big year next year to make sure that this wasn't just a fluke. So.
Great, thank you so much. So we're gonna go ahead and move into questions. Again, you're welcome to drop questions in the chat, or you can raise your hand and we'll have our presenters answer questions while you're raising hands, thinking of those questions. I'm also just gonna share that, assuming that we aren't impacted by anything later this week, that we also have our annual community grant symposium this Thursday evening. So if you enjoyed hearing about these projects in our local waterways, we'll have a lot more that are coming to present that were funded through our community grant program, and that's going to be free. It's open to the public, so we hope you will come and join us, and I will drop that link with the registration and details in the chat as well. I don't see any hands yet. All right, we've got a question in the chat. Are there predators the same for scallops? Or are the predators the same for scallops, the same in our area as other locations? Are there any theories on why scallops disappeared so quickly?
Okay, I'll take the first part of that, and then Thomas can fill in. You know, what we saw, it's going to be a combination of things. Yeah, we looked at water quality. One of the things, I got another project, we're looking at the salinity, because just like turtle grass, scallops needed at least 20 parts per thousand or higher. With all the rainfall and development going on in the area, we were interested in whether or not there was enough runoff to actually lower the salinity and cause problems. Did that happen back in the 60s? I don't know. But they looked at water quality, obviously habitat loss. Haley brought up all the things that were going on at that time with seagrasses, and they are so closely associated with that. And then you've got to throw in over harvesting. So we believe it was a combination of all of those things that caused the massive decline. The predator situation was real interesting. Chips Kirstenfeld was involved in a project when he was working with DEP several years ago, where they were trying to reseed Big Lagoon. And talking to him afterwards, he said one of the things they noticed that the scallops were kind of being piled up, and it turned out to be the blue crabs that were doing it. And of course, there were humans going out and taking them as well. We got to, we're trying to get that word out too. Now that you guys are hearing they're there, please leave them alone. So yeah, the blue crab is something, and so we're going to add that to our data sheet. We did by mouth this year. Let us know how many blue crabs. And the crown conchs, if you're familiar with that, that's a predatory snail that's been known to prey on a variety of different mollusks, but scallops are on the menu. And I have noticed, just anecdotally, their numbers have kind of increased over the last few years. And so now we're trying to track that. Is that going to be something to look at as far as any kind of success of scallops coming back? I don't know, Thomas, you want to add something?
Yeah, and another thing I can add, with the scallops, where their population is, I had mentioned that the currents, they stay in the water column for 10 to 12 days. If they do end up spawning and we have a really big rain event or something like that, and it flushes the bay, that can cause the larval scallops or the the veligers to be out in the ocean or in the Gulf of Mexico. If they get sucked out there, there's no seagrasses for them to attach to, and they fall out. That could be another theory that we're dealing with, but water quality was usually the number one, and then overst harvesting. That's something that I wanted to touch base on. Yes, we're saying that we're finding them. If you find them, please leave them be. They need as many scallops as they can out in the water so they can respawn and repopulate the area.
I will add also on the predator list are lightning whelks and horse conchs, which were abundant and have kind of declined. So we're going to start tracking and monitoring those. And I will add that we did have volunteers tell us that they found sea urchins and sand dollars while they were surveying, which is something we have not been seeing. So again, as Haley brought up the tropicalization kind of thing, this isn't really a tropicalization, but things that were gone and are coming back. So we'll have a couple of those that we'll keep an eye on.
Haley, I think there's a question for you in the chat. Zach is asking, how do stargrass salinity and light tolerances compare to the other local species?
That is a great question, Zach. And I am not 100% sure. I think they are a little bit more tolerant of temperature, but I don't know if anybody else on the call knows much about stargrass, but I don't know with certainty, Zach, but I will look it up for you.
All right, we've got another question in the chat from Dan. Any transect counts for Little Sabine Bay area? His son actually counted a few there in the past couple months. Worked with Rick a number of years ago on the Scallop project in Santa Rosa Sound. Still working on water quality in Little Sabine Bay, so hopefully we'll also improve seeing more diversity of sea life in there. So good sign. So asking about Little Sabines.
Yeah, historically they were there. This year, no one selected the site, so it was not monitored this year.
But more folks are going to sign up with Thomas, and y'all have it covered next year.
Yes, we need it.
See any hands raised? Any last questions from anyone? Again, you're welcome to reach out via email as well with any follow-up questions. We can get those directed to folks. One last thing I want to share is we do have trivia tomorrow night at Algo Brewing from 7 to 9 p.m. That one should be moving forward no matter what. So come out and join us for that free event. And then to help support all the work we do, we have our annual Evening for the Estuaries fundraiser gala coming up in October at the Coastal Art Center of Orange Beach. It's going to be a lovely evening, live music, open bar, local oysters, a great silent auction lineup. So we hope you can come out and join us for that as well and support the work we do. And if you also want to come out and volunteer, we have some volunteer shifts that we need some help making the magic behind the scenes happen as well. So I'm going to drop that link for the tickets in the chat. The last day to buy tickets is October 3rd, so just around the corner. All right, and Thomas just dropped his email for anyone who wants to volunteer, so make sure you take that down as well. All right, if there's no other questions, just want to thank our presenters today for helping us kick off National Estuaries Week. And again, fingers crossed for the weather that y'all have a chance to get out and explore and enjoy our estuaries this week. Thanks, everyone. Have a great day.